Dear students, in third year organic chemistry, the unit number 1 is optical isomerism. So first we want to know what is meant by isomerism. That is, isomerism are compounds having same molecular formula but differ in physical or chemical or both physical and chemical properties. Okay, normally is isomerism. So isomers are compounds having same molecular formula. Formula will be same but differ in physical or chemical, or sometimes both physical and chemical properties are called as a isomers. The phenomenon is known as a isomerism. Normally isomerism is broadly classified into two types, that is structural isomerism, stereoisomerism. Structural isomerism we are studied in the earlier classes, that is chain isomerism, position, linkage, that are all structural isomerism. So we are not included in this unit. So stereoisomerism, again it is classified into three types, that is optical isomerism, geometrical isomerism, conformational isomerism. Okay, in this unit we are discussing only about for the optical isomerism. The unit number 2 having geometrical as well as conformational isomerism. So first of all we want to know what is meant by optical isomerism. So it is otherwise called as a enantiomerism. Okay, it is a type of stereoisomerism which compound have same structural formula but different configurations and have equal and opposite character towards plane polarized light. Okay, it's having almost the point about the isomerism definition. It is a almost compounds having same structural formula but it different in configuration. So configuration means it is about the rotation. Okay, it is rotate the plane polarized light in a different way. Okay, either plus or minus, that is clockwise or anti-clockwise. That is example is lactic acid. So rotate the plane polarized light in the clockwise direction is called as a plus lactic acid, or dextrolactic acid. It is clockwise direction is called as a levio, that is called as a negative lactic acid. Okay, the next we want to look to elements of symmetry, because the elements of symmetry and optical isomerism having good relation. So first of all we thoroughly know about elements of symmetry, then we go for the asymmetry, then we look for the what are the components or what are the compounds are involved in the optical isomerism. Okay, that's point of view. We look through elements of symmetry. So symmetry elements of molecule are four types. Okay, that is, first one is plane of symmetry, second one is center of symmetry, third one is axis of symmetry, fourth one is alternating axis of symmetry. Okay, there's a four kinds of symmetry. We discussed one by one. Okay, so plane of symmetry, center of symmetry, axis of symmetry, alternating axis of symmetry. So first we look through the plane of symmetry. Okay, so that is nothing but it is a plane that cuts the molecule into two equal halves. Okay, so if you look the example you can easily find out. Okay, if you use the example is mesotartaric acid. In the mesotartaric acid a plane is drawing, so this dotted line is this dotted line, a plane is drawing. Okay, the plane is cut the molecule to two equal halves. Okay, so you can throw the plane is cutting the molecule into two equal divisions. That is called as a plane of symmetry. Okay, the second one is a center of symmetry. Center of symmetry is nothing but it is a point which line when drawn on one side and produced at equal distance on the other side will meet identical points in the molecule. Okay, so it is understanding means it is somewhat difficult, so I will explain more and more in center of symmetry. You look through the points. Okay, you can see the points in the example. Okay, this is the points. Okay, so a line is drawing through the points. Okay, the line is meet in the opposite side in equal distance on the identical group. So you can through the line is drawn, it is meet the COOH, and the another side is meet the COH. So we can easily understand the line is drawn through one point, it meet the same group in the equal distance in the either side. Okay, that is called as a center of symmetry. Okay, the next one is will be axis of symmetry. Okay, this is also new to you. So axis of symmetry is we can fix one angle. Okay, that is called as a one axis. That is means by axis of symmetry is an axis through which one complete rotation 360 degree of a molecule will result in more than one identical structure. So I am taking the example of H2O. We are knowing the formula of H2O, 2 hydrogen and 1 oxygen. Here I put an oxygen and 2 hydrogen. One is A hydrogen, one is a B hydrogen. Okay, this is an principal axis. This axis will be this is the axis used for a rotation through the molecule. Okay, so we rotated 360 degree. This molecule is rotated to 360 degree, but we can get identical configuration as the one time. That is, you can look at one rotation is around 180 degree. The A will be go the other side, B will go the other side. Okay, so you can able to see B is here and A is here. Okay, A is other side. Okay, that is the axis of symmetry. Okay, so you can fix one principal axis and rotate the molecule into 360 degree. So you look at how many times it will give identical structure. Okay, so in H2O it will give in 2 times. That is first one, and after that 180 degree it will be a second one. That is called as a C2 axis. So commonly it is called as a CN axis of CN axis. Okay, commonly it is called as a CN axis. That is called as a axis of symmetry. Okay, so next one is an alternating axis of symmetry. Okay, it is having some other meanings. So when a molecule rotated by an angle, again just we tell this axis of symmetry is 360 degree and reflected across a plane at a right angle to axis, another identical structure is obtained. So I can simply tell us that rotation followed by an reflection. Okay, so symbol meaning is alternating axis of symmetry. Symbol meaning is rotation followed by a reflection. Okay, so one rotation, one structure is found. Okay, then one reflection at right angles of the rotating angle. Okay, so if we consider this an example, okay, this is a rotating axis. So this is a rotating axis. Okay, this is the rotating axis. So rotating 180 degree, 360 degree by 2, 180 degree. So we can get CH3, this CH3 goes other side, that CH3 comes in this side. Okay, so we can get an appearance of this molecule. Okay, so here find the difference. The CH3 comes here, this CH3 goes there, that means that CH3 is in the upside, another one is the downside. Okay, so you look through that one. Okay, then after rotation, reflection at right angles. So reflection at right angles means in this angle is a reflection. Okay, you can put one plane and reflected. So we are on that subside will be appear as a downside, downside will appear as a upside. Okay, so just like that, this CH3 is appear as the upside. Okay, CH3, the hydrogen will be appear as a downside. So likewise all the molecules, because it is reflected the right angles of the principal axis cut panna mari. Okay, right. So so finally we can get the structure. This structure is we are getting. So look for the structure 1 and structure 2. Okay, structure 1 and structure 3. Okay, these two structure are identical. Can you able to see these two structure are identical? So we can tell us that it is a alternating axis symmetry. There is a non-rotation followed by a reflection at the right angles. Okay, so what I'm going to tell is, say molecule which having any one of the symmetry, that is either planar symmetry or center of symmetry or axis of symmetry or alternating axis of symmetry, this molecule is called as a symmetry molecule. Okay, so any one of the symmetry, the molecule possess any one of the above four symmetry, that is called as a symmetry molecule. Okay, so the symmetry molecule that is not undergoing optical rotation. Okay, so that is will be discussed in the next class. Okay, hope you are identifying or understanding this part. Okay, so we will meet the next class. Thank you.